and welcome to IABM TV. Today I'm joined by Andrew Bond, Sales and Marketing Director at ETL Systems. Andrew, welcome to IABM TV.
Thanks so much, Ben.
So Andrew, what were ETL Systems planning on demonstrating at this year's NAB show?
Well, we were going to attend the NAB show in April, and sadly, obviously, due to changes in the global exhibitions, we've had to cancel a lot of important exhibitions. So a lot of kit is still now winging its way back, either on a boat or in an airline back to ETL, ready for the new phase of exhibitions, which will hopefully happen later this year. But the customers that were traveling over from Asia and those in America and Latin America who normally come and see us at these important industry shows like the NAB one in Las Vegas would have seen our new product ranges quite clearly. So ETL Systems is well known for its RF distribution products, which we manufacture and design here in the UK, and we have sales offices around the world. So we had two new products there, which I think were quite interesting to people. Mainly as you know, a lot of people have been focused on the new LEO constellations, and certainly satellites moving into high throughput broadcast requiring higher frequencies such as Q and V bands. So a lot of our switch matrices, which handle the downlink signals, and also our amplifiers are requiring to handle much higher frequencies. So we would have had those on at the show. And so we're well known for our Enigma switch matrices, our Vortex switch matrices, and a new range called Hurricane, which also handles fiber inputs from the satellite dishes before it goes to the master control rooms, and the signals are then sort of passed out through the satellite teleports and used by the broadcaster. So as usual, we had a good range of switches and amplifiers to make sure the RF signal from the satellite to the ground station is provided and delivered in the best quality possible, Ben.
Okay, so let's talk about the Falcon frequency converter then, Andrew. How is that enabling resilience for satellite broadcasters?
Well, we've taken, we're well known for taking a technology and actually, it's sort of same meat but different gravy, as the expression goes. Frequency converters are an important and necessary part of the RF distribution chain. They, for those who don't know, they take a raw frequency down from Ka, Ku, or C-band from the satellite and convert them down on a downlink to be handled by modems within a teleport, and then the signal is then distributed around to the various customers. And also on the uplink, they do the absolute opposite, and they upconvert the frequency back up to satellite for transmission feeds. So frequency converters, as I say, have been around a while. We've taken a fresh new look at it and launched a new range of frequency converters called the Falcon, and we've repackaged them. So a lot of our customers see us as providers of very reliable equipment. So we have done a design of redundant frequency converters, down converting from Ka and Ku band down to L band, and also we're looking at C band and IF, and obviously the reverse for up converters as well. So we're able to get dual one-to-one frequency converters in redundant configuration into our 1U Falcon chassis, and this is a real game change and step forward in the amount of density that we can offer teleport engineers, because we can now we're using less rack space, we're using less power, and we're also able to do up and down conversion in a single chassis, which is a big step forward for a lot of teleports to consider in their equipment lineup.
And so what are some of the main applications of the Falcon frequency converter?
As I said before, the applications are to handle downlink feeds from a satellite dish down to a modem. And I think going back to what I mentioned before, the redundancy is very important, certainly for the Ka band satellite frequencies. They're very prone to signal fade because of climatic conditions. And if you have main and standby dishes, you often require a redundant frequency converter to switch quickly if, for example, a feed has failed on one path, and it will seamlessly switch over to a standby path. So, for example, on very important feeds, and we were involved in the Rugby World Cup uplink and downlink recently from Japan, all our feeds were covered by a one-to-one conversion, sorry, one-to-one redundancy, so that there was no single points of failure. And I think that single point of failure design and ethos is one that's passed through a lot of our products, amplifiers, switches, and matrices as well, not just our new Falcon frequency converter range.
Okay, so Andrew, do you feel the current situation is having an impact on the reliance on satellite?
I do see it as an opportunity for satellite to remain a used technology. I think we're very well aware of 5G's introduction globally, and certainly the teleports and various other manufacturers that I've spoken to. I think satellites and the ground network needs to happen in harmony. And I think it's an opportunity in this current market to make sure that as we rely on media communications to communicate around the world, and here we are talking on Zoom at the moment, and I've had many other conference calls on various other packages such as Teams, these video and data feeds are increasing phenomenally. And I think the new satellite constellations, whether LEO, MEO, or GEO satellite constellations, need to be designed to work harmoniously with the ground network to be able to deliver streaming video to our handhelds, not just to our TVs. So I think it is a great opportunity for satellite to reinvent itself as a modern and current technology that will not be pushed aside by IP networks. Okay,
well, Andrew, thank you very much for joining us today.
Thank you very much, Ben. And it was a pleasure to contribute to the IABM feed.
Thank you. So you can find out more about everything we've discussed with Andrew today at etlsystems.com.